Hello, this is Szymon Stoma. I'm a developer of STSE application, and in this screencast I'm going to show how this application can be used. So we will start from the framework of SBOS. This is run here in the virtual machine, so this might be a little bit slower in this video, but this is more comfortable to use in such a way. And to run STSE application, we should go to the Applications menu, System Biology submenu, and STSE. Here we have 4 positions. The last one is a command which is used to update STSE environment from the SVN repository. This is the best to run it first and once to make sure that we are operating on the newest version of the package. It requires the connection to the internet. STSE IPython allows you to run IPython console with access to STSE tools, and this is run in such a way that we are sure about threads, so lots of things can be used separately, which is actually contrary to the normal Python console. Then we have 2 types of GUI applications for the STSE package. One is Cell Viewer and the second one is Cell Editor. In this tutorial I will focus on the Cell Editor, which is basically used to start with the microscopy image and try to digitize it. So I'm going to start the application right now. Now the application is started. And we see the main window of the application. So on the left we see an OpenGL component which allows you to play a little bit with the display. So here we are using a kind of viewer which is 2D, so it's adjusted to play with photos. On the right we have 4 different types of actions we can do. So actually action menu, which allows us to configure the actions which are taken from the submenu. They are used to perform different tasks on the structure we are editing. Visualization, which somehow allows us to tune up some things about how the display looks like. Selected center, which will be explained later, like it contains the information about the actual chosen cell. And help, which basically describes the shortcuts of the application and the main navigation. So to start, let's load the background. This is basically the microscopy image, but in this tutorial I will use some artificial data just to test it. On the SBOS DVD you can find the data in USR, local, STSE, then trunk, data, and we'll use the thing which is called test gradient. So before doing this, I will just add for myself the data folder. So next time I will like to open this thing, this directory should be accessible here. So I will do it once again. I load background. I have the data submenu here. I'm choosing the test gradient. So I click, and in test gradient I'm just choosing untitled PNG. This is basically an image which contains some of gray, some of white, some of black, and some kind of gradient going. So we can zoom out, zoom in. This is what we do with mouse. And now we can perform to prepare a digital form of this image. By doing this, basically we want to cover the image with a kind of mesh, and to do that we use the action which is called add Voronoi centers. So here we have some configuration of this thing. First of all, we can choose whether this is grid or random placement of the Voronoi centers. I will choose the grid one. Then there are some conditions on which the the Voronoi centers will be converted into mesh. Basically, there will be a kind of rectangle, and all the compartments which are whole inside of this rectangle with these coordinates will be taken into account by creating a mesh. What is important here is the number of centers which we want to use. So for example, here I'm using the default value of 100. So when I loaded the image, actually these values which are here, they were set to match perfectly the size of the image. So the 0, 0 coordinate will be here at the beginning on the left bottom corner of the image. The right top would be set to this one. If we want to set it manually, we can use a cut plane. So I'm showing the cut plane right now. And now I'm able to somehow tune what kind of values for this object I want to have. So I will set it more or less like this one, like it was before. Now we can turn it off. So first I will turn off this marker because we don't need it. I can turn off cut plane, just do not bother with this. And now I'm executing the action of creating Voronoi centers. So this is what I'm doing now. Now we have centers, and these centers which formed the Voronoi diagram, which were placed in the constraints which are defined using the cut plane, actually are displayed. The ones which are here, they have some infinite borders, so they are cut out. Now we can start inspecting the grid. So for example, we can select a center. To do that, we go around the center and we press P. And we know that the center is of cell type A, and it has some default properties which are set here. So for example, I can change the type of the cell center. So this is now, it is B. It will refresh itself when I will change to a different thing. So for example, on the default viewer, it is set up that the different types have different colors. And what is the most important, we can start changing the shape of this thing. Simply, we need to select a center, and I just use Shift right now to translate a little bit my mesh. So I Shift and left click with my mouse, and now I'm able to drag the center, and now I'm dragging it. When I will leave it, a new Voronoi shape of this mesh will be computed. So this is what is happening right now. It is running quite slow here, but on some faster computers with multiple cores, it's computed in parallel, but in principle this works quite efficiently up to 2000 Voronoi fragments. So this is what I can do. Maybe I shouldn't play with this too much because I want to use some properties of this grid, but for the moment let's try. And now we can, for example, change the way it looks. So for example, if we want to see the center bigger, we can just increase them up to some values. When they are too big, they form some strange properties. Then we can say that we want to see the value of the properties as a color map of this mesh. So this is what I'm doing. Now every property on this mesh has a value which is kind of 0. So actually the mesh will use some default jet map, so which means that all values should be in principle set to 0. So we see that all things on the mesh are 0. I can, for example, set this selected center to 1, and we should see that the color should change. To do the refresh thing, we should do the update edges from here. It's done that way since the refresh is not always necessary and it takes some time, so it's a kind of choice of user whether he wants to perform this thing.